Okay, so yeah, today we are going to start talking about next generation neural interfaces. And our reading for this week was a fairly recent paper which appeared in ACMC Chi 2019. And it's really relevant to where we have artificial intelligence now appearing in everyday life. So today we are going to see the adaptive interfaces, which actually are a type of intelligent interfaces, and which we are going to see how artificial intelligence can be applied in some of these interfaces. Modeling the user, we are going to see how we can model the user and represent user profile as a probabilistic model. So this is maybe the one of the most technical part of the course this semester. You'll see a statistical model called hidden Markov models today. I'm not going to go into too much detail of it, but you'll at least understand how we can use them to represent a group of users or a group of objects probabilistically. All right. So and also I like reading this week's paper. It was not very technical, but it touched upon lots of things like evaluation. We have talked about how we can evaluate the predictive and interpretive evaluation, how they use predictive evaluation to evaluate certain existing applications. They didn't need to. If you read the paper for today, you must have seen that they have tested a lot of applications. And so they didn't build the applications by themselves, but they tested them in terms of their usability, how they satisfy the guidelines that they set. And by doing that, actually, their goal was not to only to evaluate the applications, but to evaluate the guidelines themselves. So they did use predictive evaluation. They did not apply actual users. The users were all usability experts that they had in their experiments. But it was nice. I mean, even the experts had difficulties in understanding some of the guidelines. Some of the guidelines were misinterpreted. There were probably some ambiguity. So they reworded them. They rewritten those guidelines so that they became more specific, less ambiguous. So, there are still lots of things to do. The guidelines are really generic. Trying to come up with, compile a set of generic guidelines for that will be applicable for all types of applications is really difficult. So there are certain artificial intelligence techniques which are available or certain features which are available in only um, some of the applications. Okay, so there are different applications have different purposes, but still they made a good attempt, in my opinion, to produce these guidelines. So whoever is going to use artificial intelligence to generate some intelligent interfaces, some interfaces that adapts to users' needs, it's really important to take into account those considerations. Okay, so they also mentioned some of the things that we're going to talk today, especially some drawbacks of adaptive interfaces like their predictability. They are being non-consistent, non-deterministic. So these things are make adaptive interfaces uh, uh, that their chance of being accepted by the users diminishes as they are become more unpredictable. But there are still doesn't mean that we are never going to use them if these guidelines are taken into account. It's always possible to have acceptance in intelligent adaptive interfaces in our daily lives too. All right, so today we are going to have our quiz. The quiz is already on OttoClass, so it's going to be open. Uh, so quizzes right here in the week of April 26th, May 2nd. So here is quiz 4. It's going to be open about 1 hour from now, 55 minutes from now. You'll be able to answer quiz questions, and it will be open for 10 minutes. Yeah, next week we are going to continue we have set our midterm exam for next week. Actually, it may be we will not have a reading for next week, and we are going to have the midterm exam, but I'm going to have it as a take home, which you'll be able to work over the weekend. All right, so I will give 2 days for the midterm exam. We are not going to have any class next week, no reading assignment, and you will have a chance to work on the midterm exam for the entire weekend. Okay, so that's for next week. And after that, there is the spring break, I think. This schedule actually does not show the up to date schedule. We are going to have our spring break right here. Let me just take a look at my calendar. Somewhere here, yeah, in the week of where we have the Bayram, there's also the spring break. So we are not going to have a class on 14th of May. You're not going to have a class. Okay, so I will make announcements about that. So 8th of May, we are going to 8th of May, we are going to have our midterm exam next week, and it's going to be take home and will be available for the whole weekend. So you will be able to submit your midterm exams over the weekend. And on May 14th, we are not going to have a class because it's the spring break, official spring break, as indicated in the academic calendar on student affairs. Okay, so we don't have any readings for the next 2 weeks, and we're then going to continue after the spring break. We're going to continue with three-dimensional user interfaces, virtual reality, augmented reality, and as such. Okay, does anybody have any questions about these things, about the midterm we are going to have next Friday, or any other thing? And also another important announcement that I want to make is your project proposals. Don't forget to submit a one-page short project proposal, and all the papers you have read up to now should give you some idea about. So there are still unsubmitted lots of groups which did not submit their proposals. So you still have 2 days to work on the proposal for 2 days, but don't forget to submit your proposals by Sunday midnight. It's okay if you submit it a little bit late. It's okay if you submit it on Monday, but yeah, you should submit no more than a day latest at least. It's just going to be just one-page report proposal, so it will help you to get started on your projects as soon as possible. All right, so let's start talking about user modeling. So let me download this on my desktop. All right, so here's Weekman. So user modeling and adaptive interfaces. Let me just leave it in continuous mode. All right, change my mouse pointer size. All right. So we are going to see two types of interfaces when we talk about adaptive interfaces. There are, in terms of customization of an user interface based on user needs, there are different types of adaptation. Most of the time we have, or most applications already provide adaptable, which means customizable interfaces, which allow user to customize certain things. For example, I can play with this window. I can, for example, when I say view, I can have show hide the tools pane. I can show it here, or I can have the page control toolbar items. I can show hide quick tools. So where was the quick tools? Since I didn't use, I didn't even see it being hidden. But what I mean is that when we have interfaces like this, yeah, I think it was the quick tools were somewhere here. So it allows users to customize the interface on their own, especially when the tool provides many functions. Having all those toolbars, menus, all in a crowded environment is not a good way to present those functions. So adaptable interfaces, basically, they allow users to customize the interface according to their needs. They can get rid of certain panes. They can move around different things. So basically, that's what adaptable is. Adaptable is customizable manually by user intervention. Adaptive interfaces, on the other hand, they adapt themselves automatically. And the simplest example of adaptive interfaces is this Windows menu, start menu, for example. When you click on this, for example, most frequently accessed applications may appear here in quick access. All right, so or when you have these pull down menus, some of them, if it contains a huge list of menu items here, when you just click on it first, it may show the most frequently used items only. The others may be hidden, and you may need to press another button to actually populate the entire pull down menu. So this way of just using the frequency of items to adapt a certain pull down menu or some pop-up menu is the simplest example of adaptive interfaces. Basically, the idea is for the interface to adapt itself automatically. So the term adaptive means automatic adaptation without or with minimum user intervention. So in order to be adaptive automatically, there should be some intelligence built in the interface. This intelligence can be as simple as maintaining frequencies, or it may be as complicated as predicting the user actions. Okay, by predicting what the user is doing, by predicting the main task at a high level, and adapting itself automatically according to users' needs and providing users options by predicting what the user is most likely to do, the interface becomes adaptive. For example, if many TVs like Netflix, Amazon Prime, these are actually examples of adaptive interfaces because based on the movies you have watched, your home menu always, your home window always changes by having recommendations that are closer to what you have liked or what you have watched. So this is like information filtering or recommending users based on users' potential interest is one example of being adaptive. There are other things that are the other examples we can give. And in the paper that we have read, there were some example applications that this adaptation in the terms of information filtering or recommendation was provided. There are also interfaces which use both of them in some flavor, in some combination. These are called mixed initiative interfaces, which allows the user to be in some control, so it's both customizable and automatically adapting interfaces are a hybrid combination of both customizable and adaptive interfaces. So the definition of adaptive interfaces came out as early as in 1999. So here the keywords are, as you can see, invoke machine learning or AI, artificial intelligence, to improve their interaction with humans. So they are interacting systems, they adapt themselves automatically to users' needs. So that's the definition of adaptive interfaces. And I already mentioned adaptive versus adaptable, but these are some key characteristics. and some advantages, pros and cons of adaptive versus adaptable. So adaptive, the system adapts automatically to tasks and users. So there is some knowledge contained within the system. Whatever machine learning algorithm is applied, whether you're using frequencies to update those menus or some other probabilistic model that you're maintaining, that there's some knowledge contained in the system. And this knowledge may continuously be updated uh, during user interaction. The system may be training itself along the uh, usage history. So this knowledge is not something, may not be something static. It may be dynamic. So that's actually not shown as a disadvantage, but so there's some knowledge contained in the system. But if it is hidden from the user, if it's not made transparent, the cognitive, the conceptual model that the user is going to have may not match what this knowledge, and the system may not be predictable. But the most important pros, the advantage of this adaptive system is that little or no effort is needed from the user. So it actually takes the burden of customization or doing things manually from the user, and it helps the user automatically. So little or no effort needed from the user is the biggest advantage, and that's why we need adaptive systems. But one of the usability guidelines or heuristics, that is in golden rules, Schneiderman's golden rules, or Nielsen's guidelines, we have seen those design principles, is the user should always feel in control. If the user feels the user is not in control, it's like randomly interacting with a system. That's not going to be a good experience. So one of the disadvantages, biggest disadvantages also of these adaptive systems, is that the loss of user control. So these two things, little or no effort and loss of user controls, are two competing features, right? If you want the user to be more in control, the user has to put some effort in it. Or maybe you may find some good balance between them. Without too much effort, the user may still feel in control. For example, if there are going to be certain actions that are going to be done automatically, the system should at least make the user know what will happen. So it may try to become as transparent as possible. So there are some guidelines actually that we had in the paper that we have read last week about how this user control can be maintained by taking into account certain features of these adaptive systems. Adaptable, or the same, we can also say customizable. The adaptable interfaces are also maybe named as customizable because the user has to spend some effort to adapt itself, to adapt the system to their need. Users can change the functionality of the system. The knowledge of the system is extended by the user. So the user is in full control. But the disadvantage, on the other hand, is that user must do substantial work. For example, there are certain 3D modeling tools like Blender with lots of menus. There are, for example, three screens, three-dimensional views that you see at the same time. But most users probably use the default Blender view, where, for example, the three main cameras are there. Certain properties are on the right-hand side. Object properties or assets are at the bottom, or things like that. So, or the animation control is at the bottom. So, when we have applications with many functionalities, advanced users, they spend actually, when they first install the tool on a new machine, advanced users actually spend some time, maybe an hour, to get back from the default mode to some customized mode. This is also true in games. So games are adaptable in terms of, for example, the game controls. If certain users are used to certain types of controls, especially when you're using first-person shooter games with lots of if you're using mouse and keyboard together with lots of modifier keys, for example, running or sprinting or getting into prone position, jumping. So you probably most of the time you're using, in addition to the movement keys, you have these some modifier keys that you press, and sometimes they may be the space key, sometimes control, sometimes shift. But if different games they do not, there is no standard in the entire universal standard for these things. But each game actually uh, provide users a way to customize the keyboard mappings on their own. So this is an example of adaptable interface where the user, before starting to play the game, spends some time to change those keyboard mappings to their needs. Okay. Also, another thing about game playing is that, for example, the gameplay difficulty. That's something when you select easy, medium, hard, very hard type of difficulty before you start playing a game. That's also a customization option that is provided by the game. And the user manually selecting one of these things makes the system also adaptable or customizable. But what I usually find in such games is that if the game actually itself changes its difficulty automatically, in other words, it becomes adaptive based on players' expertise that is discovered while the user is playing the game. That will be much better, right? Because when you're playing the game first time, those easy, medium, hard, if it's a new game, completely new game, you may have no idea whatsoever what medium means. You usually must hesitate. For example, if I select medium, is it going to be too easy for me or is it going to be too difficult? So you may find yourself coming back to those settings after you play your game a week or so. You may try different settings. But if a game intelligently adapts itself automatically, if it's an adaptive game, and this difficulty adjustment in an adaptive manner automatically in such a way that the user always is in this narrow region of enjoying the game. So there is also this difficulty. If the game is too easy, it becomes boring. If it's too difficult, it becomes frustrating. So there is a narrow band of being enjoyable, and this may be changed from person to person a lot. So having games that does that automatically is really a big plus over other games. And actually, if we weren't going to have the midterm next week, I was going to the next reading assignment that I was going to give you. I will give you after the spring break, after Bayram. I will give you this assignment. It's an adaptive Tetris game. It was an automatically adaptive game application that appeared again in ACM SIG-Chi. It was about an adaptive Tetris, and the name of the paper is Adaptive Tetris, not another Z piece, something like that. Let me try to find that paper. Adaptive Tetris, not another Z piece. Yeah, this one, adaptive difficulty in Tetris. Oh, actually, the first link that comes up is my schedule page, my course page in another. So since I make this PDF freely available, fortunately ACM did not contact me to put this paper down. But yeah, probably I'm putting some copyrighted material freely available on my webpage. But it appeared in 2017 in ACM SIG-Chi, again, the flagship conference. So if you take a look at that, so it talks about, it's a short paper. As I said, I'm going to give this paper to you at least to see how adaptivity appears in games and after for the week after the Bayram. Okay, so you will have 3 weeks before we have the quiz. Okay, so this talks about how they tried different algorithms to adapt. So they had different algorithms that they experimented with to change the difficulty, and how they define the difficulty is something else. Okay, so how you define it's a difficult game or not, and how you adjust that by changing different parameters of the game. So determining the parameters of the game, determining difficulty, or determining whether the user is having difficulty or not, things like that is what this paper is about. It's really nice technical paper, and they had some experiments that they provided, and they have some nice results. Okay, so we are going to talk about that later. You will have a chance to read this paper later. All right, so basically these are the pros of customizable interfaces. So why do we have adaptive systems at all? The main idea is, I mean, if computers are there in order to enhance user experience, if they do some things intelligently, automatically, they will be like butlers, they will be like helpers of humans when they're using the system. So we really like to have intelligent interfaces to increase the user experience in these complicated interfaces. So, for example, information filtering is really important because the internet has huge information. If we don't have adaptive systems, for example, if all of the information is provided to us in one shot, it will be like browsing a big library. It may be overwhelming. The user may not find the necessary no information in time. So this is something, adaptive systems, they actually tailor themselves according to individuals' interests or shared interests. So shared interest is the techniques named collaborative filtering, takes into account the shared interest of multiple users to recommend users new content. But this one also, I think this one also has some disadvantages. I find, for example, especially this in YouTube, for example, you're always recommended videos that are similar to things that you have already watched. This, after a certain point, this actually, I think, creates like a bubble around the user's interests. And sometimes the user may want to go outside this bubble and experience or watch new things that may also be interesting. So actually information filtering somehow avoids that, and you will be always be exposed to things that are close to your near that are similar to your interests. So I think that's a disadvantage of such adaptation. From time to time, diversity is also important, and recommendation systems sometimes should break outside this bubble and show users different choices. Okay, so adaptive menus are the simplest examples of systems adapting themselves automatically to users' needs. So these are really old examples, but yeah, menu bars that change themselves, or that can be, some of them are adaptable, which means that allows you to customize. Some of them are adaptive. Most frequent items appearing in your programs, pop-up menu, things like that. The frequent application list, for example. Yeah, here's an example of the old Windows. So here, when you click on accessories, the accessories may contain maybe 20 or 30 different things, but when you click on accessories, the calculator and command prompt comes first because they are most probably, for this user, they are the most frequently used two applications. If you want to see the others, you need to click on an additional mouse button, but being presented these most frequent things first means that you'll have, instead of being faced with a crowded menu to select from them, you will have faster access to these most frequently items. The same thing happens with autocomplete, when actually instead of trying to navigate between all these different things, for example, one thing that happens is that when I was changing my mouse pointer size, so when I just say mouse, I just type here 3 letters, MOU. I'm going to come to your Ahmed's question in a second. So when I type MOU, since I change my mouse pointer size frequently when I'm in these lectures in the last couple of weeks, the best match that comes at the top is the most frequently used function. So I will directly find it at the top and will immediately go to this mouse pointer change size application. So, but if you want to do other things, the other options that are related to mouse is also available, and it shows the entire menu. But showing this at the top shows that it actually maintains the frequency of application that I use, and my search actually is ranked, ordered based on my frequency of application. So that's a good thing. That's a good thing. It allows me to access that application as fast as possible. So the good question from Ahmet is that how does YouTube show videos in order, similar to our interests? What is in the background? So there are different algorithms. And for example, in 10 years ago or so, when Netflix was not this popular, there was this $1 million Netflix competition, which actually tried to crowdsource this development of algorithms, the best algorithm to recommend the users that are movies that they are likely to watch. So it's a challenge actually. This is a research area. And I'm sure people on developers on YouTube are still trying to improve their methods in these recommendations. So these are called recommender systems, the area of research that does this YouTube video recommendation or Netflix video recommendation is the area of recommender systems. And there are different techniques that are used in the background. For example, the most common one is used collaborative filtering. Especially there's content-based filtering. Let me write them here. Let me get my whiteboard. Here, some of these information may be what you have watched. For example, your video watching history could actually be maintained for all of the users that watch YouTube. They have a history that each user can access, which is personal, okay? But that information can be made anonymous by stripping the user's credentials, username, or other things. What we may have at the end is a set of videos that are watched by a single user. So user 1 watched these videos. User 2 watch these videos. User 3 watch these videos. So what we may have is that when another new user comes in, user 4, if no if the user is just new to this system and based on just a single movie the user has watched, we may not build a good profile for this user. But what we can do is these other users, if they watch the same movie, the list in the videos that are in their list, the other videos that are in their list, and for example a consensus, by using a consensus or majority or the most frequent videos that they also watched, and what they share in common is that they also watch this single video this user 4 has watched. So even if this user watch has a single video, we can, by using this is called collaborative filtering, with the help of collaborative filtering, we can actually transfer other users' profile information in an anonymous way to recommend videos to this user. So it's just like in Amazon or in other shopping sites, the users who bought this also bought that. The same idea applies. The exact algorithm to make these recommendations are probably not public, what YouTube uses. We may not know. Different websites may use different things, but they have these usage history. Our viewing history is what they use. And also another important thing that we can have is content-based filtering. Okay, they're not content-based filtering. So instead of using other users, what we can do is, okay, content-based filtering doesn't use other users. instead of but it uses what is this that you watched, what kind of, for example, if it's a movie that you have watched, the easiest case of content-based filtering is done by some the metadata related to this movie. For example, who is the director, who are the actors. If you like this movie a lot, you will probably like the movies in which this actor or directed by the same director or the same actors playing in this other movie. So we actually look into the content of the video, and the easiest thing to do these days is by looking at its metadata, its genre. For example, was this a comedy movie? Who directed it? Who are the producers? What year was that? So, but the actual content-based filtering, the more technical and that one that is going to be useful, is to generate certain numerical features directly from the movie content itself. For example, the number of, if it's a scary movie, okay, for example, if it's a scary movie, I can tell you one feature about scary movies. The what is it? I forgot the term. The scare jump scare. Yeah. How many jump scares does this movie contain? That number, for example, if it a scene where it makes you jump. Okay, let's name these the number of jump scares a scary movie has. For example, if the user liked that movie, I can just process this movie's content automatically to compute this jump scare number of a movie and write it as a metadata that is automatically computed by some video processing tools. Or, for example, it may be anything. So these features, as you can see, are limited by your imagination. You can have, for example, if you like this movie, you may have liked it because it has many green scenes in it with lots of trees, fields, green fields. Maybe you have liked it because it contains lots of birds. So how do you process the content of a movie? And not just the contents of objects. For example, how do you uh, analyze it, the movie, to, for example, whether the story proceeds smoothly, whether the movie has, for example, a plot twist. For example, is there a twist in the plot which you were expecting something but something else happened? So how do you detect a plot twist in a video, in a movie? I think that's, I mean, you can write master's thesis on these things. These are problems that are still not solved, okay, understanding movies. So this content-based filtering is therefore, it's trying to analyze the content of the movie and extract certain features by processing the movie and then using other movies with similar features. So how do you find that? That's also another problem. How do you find in your, there's the movie database, all the other movies should be processed in a similar manner, and your goal will be to find with some similarity function to find movies with similar content. This content-based filtering is used a lot, especially not only in movies, but in books, for example. This may be easier to do because books are, they contain words. For example, we can have a certain number of keywords, like 2,000 words that appear in books that have certain characteristics. And based on how many of these words the book contains, that may be a feature about that book. So there's this term frequency, inverse document frequency feature that is used a lot in these content-based filtering of books. TF-IDF. You may have heard this if you have taken a data mining course. Maybe, I mean, if you're taking data mining course from Ayşenur Hoca this semester, she may have mentioned this term. Term frequency, inverse document frequency. So what it means is that if a term appears a lot in a document, it means that it's something important with this. Something this book maybe is about that. For example, if the term computer appears a lot in the book, yeah, it may be, the book may be about computers. But if you say that, okay, the word the appears a lot in the book, of course, right? I mean, the appears in every English book. So which basically says that just the term frequency alone, just because the word appears a lot in a document, it doesn't mean it's really important. So here comes the other factor, inverse document frequency, which means that a term that appear in less documents may be something a characteristic term, and if some book contain this characteristic term a lot, so term frequency and inverse document frequency is used together. They are used together to indicate some feature about book. So content-based filtering is applicable in images. If you're browsing images, it's showing you images that are similar in content. And an image is just a single frame of a video, for example. It's just a single thing. So extracting features from images or from books are much easier than extracting features from videos. And especially content-based filtering will be really useful if the video processing, I'm sure people are still doing research on just not processing videos, but for example, processing news feeds, video feeds of news channels to query, for example, certain particular news, or browsing sports events. If you want to browse sport events, you have to, if you can process the content, for example, to automatically detect goals. I think there must be techniques or tools to do that. In a football match, for example, uh, if you just want to watch the summary of that football game and just where some important action is happening, goals are one thing, red cards, for example, are other things. So, which are the important events in a football game? And how can you detect those things automatically by processing the video automatically? So, these are really challenging things. Yeah, so you can. There is also another good thing that Ahmet mentions in his question is that categorizing people. So, people with similar interests, if we group them together, and so this is basically creating a profile of similar users. For example, maybe young people in Turkey are watching different YouTube videos than elderly people in, for example, Spain. So if you, I mean, these are, I mean, but just by just looking at the metadata, are you living in Spain? What is your age? Instead of categorizing people by just their demographic information, these user profiling, the categorization of people actually can be done according to their behavior. So if we have the user's history, the behavior for a certain number of months or years, for example, we would be able to use them to figure out which users are similar to which other users in terms of their movie watching history, and then recommend movies based on that. So yeah, categorization. This is basically called user profiling, and it's also used a lot. So there are different things. So there is the content, there are the users, there are similarities between users, there are similarities between content. So this is all taken into account when uh, we are in recommender systems. So this is an interesting idea, area, research area, and people and different companies have different algorithms that they use to do these things. And this brings us to our next topic, user models. How do you, yeah, you're welcome. And how do you model a single users, for example, if a single user has a history of YouTube movies that they watch, how do you represent that? Do you just represent it as a raw sequence of video titles? Or maybe do you say that, okay, this user watches on the weekends some sports videos, maybe on weekday, mostly music videos? So understanding from the context, for example, time, when something is watched more. If YouTube, for example, wants to develop a better algorithm, I don't think they do that right now, but we could have different recommendations based on different time of day or week of day. If YouTube is intelligent enough, for example, on weekends, they may recommend me different movies than what I watched on weekdays. Okay, so and so just not the history of movies, but how do you uh, model this user in terms of the history of watched videos? So we need to have some higher level probabilistic model of the user to be able to make these things. And there are different aspects of it. First, how do you build the model? What type of data you use? What kind of logs or history you use? And then other thing is, after you have this model, how do you apply it? If somebody gives you a model of the user, how do you use it to adapt the system automatically or to recommend? So these are all interesting, important parts of adaptive interfaces and user modeling. So there are different ways to first build the user model. Most of the websites, for example, when you just subscribe or enter their login as a user, uh, you first fill in some sign up form where you may click on certain your interest. So the data collection can be, you may report your interest when you're signing up for that website. Another thing is these cookies that websites use. Certain websites, in order to personalize your to your needs, some sites you may not want to sign in, give your personal information, but they may collect this information based on your IP or based on the cookies that are stored on that computer. They can figure out that, oh, okay, this is the same user that is doing these things. So, but this may also lead to incorrect user models. For example, if a machine is used by multiple people uh, during a week, if a desktop or if a laptop is used by multiple people, and if the same cookies are stored, and if these people behave differently, the machine is just going to, whatever algorithm that you're having to build those user models, they're going to just assume that it's the same person, a single person behaving differently in different times of the day, but it may actually be different people. Okay, so collecting therefore data just based on cookies is not as reliable as a user who has signed in. So therefore, for example, when you sign in on YouTube, uh, based on your history, it may recommend you better movies. So first, identification of the user. Who is this person? Have I seen this person before? That's even a challenge by itself. All right. So, and after that, different interfaces. So, okay, YouTube is just one example, but there are interfaces which are just tools that you use. So, uh, how do you keep track of, for example, user actions when the user is using these tools? Like do you track the clicks that the user has made? Do you maintain the frequency of certain menu items that are being used? So data collection is one part. Usually this data, when collected raw, it has to be summarized to build into a user model. And user models that after they're constructed, they can be used in different things. Adaptive user interfaces is one thing, recommender system, adaptive system, information filtering or personalization. So user modeling is also called user profiling. If you see user profiling, it means building user models. There may be different ways to capture user preferences. There may be handcrafted stereotypical models, like YouTube probably have these. They may have these stereotypical models saying that young watchers, elderly watchers, or geeks who watch YouTube, or nature lovers, cat lovers. So there may be different stereotypes of people who watch YouTube videos, and there some of them may be handcrafted if you have a collection of these users. But sometimes you may collect some data from the user. And another thing is the user model can be dynamically learned and updated as the user continuously use the system. So we can actually have a statistical model of a user without collecting data from the user manually at the beginning. And collaborative means that we also use other users' profiles when trying to build this single user's model. Collaborative means with the help of other users' profiles. Or it may be an individual model. So there are many different choices that we can make when we are doing this user modeling. So I already mentioned what collaborative profiling, and one particular aspect of that is called application of that is called collaborative filtering. Association by user and object. The users who bought, who bought this item, which you just bought, also bought these other items, things like that. And this is Amazon uses this a lot. For example, if you bought something, if you bought these things, the other users, today's recommendations for you. Here's a daily sample of items based on probably I just bought some micro SD cards those days, or maybe I did something for I bought something for a camera, and therefore Amazon recommends me camera related things. Okay, so these are recommendations, and the data used to develop user profiles may be different things I mentioned. Navigation data, the content of what we have, the content of the things that we have watched or bought, the metadata that is related to that. These are some implicit data that YouTube collects from us. But it's from time to time when you, for example, usually this explicit data collection happens in the first step when you're signing up. When you're signing up for a new service, they usually you have to fill a form, like user preferences, which do you like. But the disadvantage of this explicit data collection is that it shouldn't take too much time of the user. If signing up to a system takes half an hour, you will have very few users to complete that data collection signing up procedure. So it has to be as short as possible, and which means that you cannot collect too much data during sign up. Here, the basics of user modeling is that we first collect as much as whatever data we can collect about individual users, we collect those different types of data. Then we process this data. This raw data is then processed to develop either a mathematical or a statistical model to represent those user frequency preferences. It may be a list of items, it may be a list of, it may just be a set of things, or it may be some frequency values, or the preferences of the user scaled based on whether I very much like it, medium, or I dislike this, things like that. And after that, after we have the user model, the next step is to apply the user model automatically to adapt the appearance of a system. And such systems that adapt themselves automatically are called adaptive user interfaces or intelligent user interfaces. Here, this figure from a 2002 article on the communication of the ACM magazine, from adaptive hypermedia to the adaptive web. So everything around us is adapting itself to our needs. And as I said, it may have disadvantages, but here's a overall pipeline of the system. So the system collects data. The system is responsible for collecting data about the user. The data about the user is used to build a user model. And when we apply this user model, we call this the adaptation effect. The adaptation is the application of this user model to change the system, actually. So this adaptation actually changes the system's appearance or interface. So what they indicate here, system, I think, is the inner knowledge, which is probably not changed. But this user modeling and adaptations are some key critical steps during this. And here's our elements of an adaptive interface, the same. So we have the interface. There's a user using the interface. So we collect data to build the user model. The adaptive algorithm both collects the data from the human user. It builds a user model, and using that, it changes the user interface automatically. Here are some more examples of data that can be collected. The time stamp of certain usage, the referring URL, which operating system you're using this from, the user ID, number of visited pages, or number of things that are viewed, From this huge collected raw data, you may apply pattern discovery algorithms to summarize the data you have. And some explicit data that can be collected in the form of questionnaires or sign up forms are these. I'm going to skip these. Oh, Google had a project like maybe in the 10 years ago or maybe 15 years ago, or very early on. There was Google personalized beta. I think Google is now, maybe our Google searches probably are personalized based on location. You can actually turn off location, but usually when you do a Google search, it does some adaptive things based on where you're doing the search, which computer you're searching from. But the ranked search results really are important. And this Google personalized, before it was embedded in the current Google, that was probably as a separate project from original Google search engine. Google personalized. It collected data, for example, in terms of what are your needs. Do you like social sciences, technology, astronomy, science, biology, or from science? In music, which music do you like? So after it collects data from the user, so this is explicit example of explicit data collection. After this data is collected, it then ranks the search results in such a way that the web pages that are more similar to your interests are ranked higher. Okay, now before the break, it's now break time. I'm going to talk about, we are going to jump into hidden Markov models. It's just an example of a mathematical or a statistical model to build a user profile. So this is an abstract from a poster, it's the abstract of a technical report. So using a hidden Markov model to learn user browsing patterns for focused web crawling. So if you are going to develop a search engine that is just for a specific user, if you want to tune it to that user's needs, this is what you can do. Use hidden Markov models to build a user model for the browsing patterns. So browsing patterns is the raw data that is collected, and by using that, you can build a statistical model, and that's what we're going to see after the quiz and the break. So let's have a 12-minute break until the quiz closes. All right. So I'm going to stop recording now.